Hello everyone, welcome to EquaticMaths. Today we are going to discuss Chapter 1 of Class 10th Real Numbers Part 2. So let's start with our topic. Today we are going to discuss HCF and LCM. So first of all, let's see what is HCF. HCF is highest common factor. What is the meaning of highest common factor? The highest common factor of two numbers is the highest possible number that divides both the numbers completely. Means अगर दो numbers हैं उनका HCF हमें find करना है तो उन दो numbers के वो possible number, वो highest possible number जो उन दोनों numbers को completely divide करे, that is highest common factor. Now see how to find the HCF. See this example. Find the HCF of 8 and 12. Now to find the HCF, we first have to find the prime factorization of 8 and 12. For 8, if we find out the prime factorization of 8, then on 2 we will get 4, then again on 2 we will get 2, and again on 2 we get 1. So we can write 8 as 2 multiply 2 multiply 2, right? And if we see the prime factorization of 12, then it is on 2 we get 6, again on 2 we get 3, and then on 3 we get 1. So the prime factorization of 12 is 2 multiply 2 multiply 3. This is the prime factorization of 8 and this is the prime factorization of 12. Now to find the HCF, we have to see the highest common factor. Common factor means which is in both the numbers, and highest means the maximum possible. So for 8 and 12 we can see that 2 is in both the numbers, again 2 is in both the numbers. Now this 2 is only for 8 and not for 12, and similarly this 3 is only for 12 and not for 8. So these are not the common factors of 8 and 12, right? But this 2 and this 2 is the common factor of 8 and 12. It means HCF of 8 and 12 is 2 multiplied by 2, that is 4. Clear? Also, one more thing, the highest common factor, we can state the highest common factor by one more term, that is greatest common divisor, GCD. We can also name it as greatest common divisor. Okay. Now see the next thing. What is LCM now? LCM is least common multiple. Least common multiple is the LCM. What is the meaning of least common multiple? It is the LCM of two numbers is the lowest possible number that can be divisible by both the numbers. Lowest common multiple में ऐसे numbers आते हैं जो दोनों numbers को divide करते हो least possibly, मतलब कम से कम possibility जिसकी होगी ना वो भी LCM में आएगा. Let me explain by an example. See, we have the same numbers 8 and 12 here, and now we have to find the LCM. In the previous example, we just saw now that 8, we can write 8 as 2 multiply 2, right? And we can write 12 as 2 multiply 3. Now, what is the meaning of least common multiple? It means the common factors, we have to take the common factors, but we have to take all other prime factors also. Like here, these are the common ones. This 2 is also the common one. So the LCM, for LCM of 8 and 12, we have to write this 2 and this 2. It is 2 multiply 2, and also this one and this one. We have to take these also for the LCM. Okay. So it is 2 multiply 2 multiply 2 multiply 3. That is 2 2s are 4, 4 2s are 8, and 8 3s are 24. So 24 is the LCM of 8 and 12. we have to take the lowest possible number that can be divisible by both the numbers. See, the lowest possible number that can be divisible by 8 and 12 is 24 here. And highest common factor means the maximum number which is common factor of both the numbers. For HCF, when we talk about the HCF of 8 and 12, the common factors are 2 and 2 only. So HCF is 4. And when we talk about the LCM, it is 24. Clear? Now see the next one. We have to find the HCF and LCM using prime factorization. We just know now what is prime factorization. Now here we have to find both HCF and LCM of both the numbers. We have 45 and 63 here. First we will do the prime factorization. When we talk about the prime factorization, we have to take the prime factors only, and we have to start from the smallest prime factor always. Okay. Now 2 is the smallest prime factor, but 45 is not divisible by 2. So we are not taking 2. Next prime factor is 3. So we are taking 3 here. On 3 we get 15. And the prime factor which divides 15 is 3. The smallest prime factor which divides 15 is 3. And then we get 5, and after that we have to divide it on 5. So the prime factorization of 45 is 3 into 3 into 5. Clear? Now for 63. 63, the smallest prime factor which divides 63 is 3 again. So we get 21. Now again on 3 we get 7. And then 7 is also a prime factor, and we know that 7 is a prime number only. So 7 will be divisible by 7 only. So it is 1. Now 63, we can write 63 as 3 into 3 into 7. See, every composite number, we learned about the composite numbers, and in composite numbers we learned that every composite number can be written as the product of primes. And that is the prime factorization, right? So here we converted the composite numbers into the product of primes. 45, we can write 45 as 3 into 3 into 5, and 63 we can write it as 3 into 3 into 7. Now to find the HCF. To find the HCF of 45 and 63, what we have to do? We have to take the common factors, highest common factors, right? Now when we talk about the highest common factors, highest common factor of 45 and 63 are 3 and 3. So we can write it as 3 multiply 3, it is 9. But when we talk about LCM of 45 and 63, it is, we have to take these common factors, 3 multiply 3, and also the other factors 5 and 7 also. So we will write 5 multiply 7. Now 3 multiply 3 is 9, 9 multiply 5 is 45, and 45 multiply 7 is 315. Clear? So the LCM of 45 and 63 is 315, and HCF of 45 and 63 is 9. Is it clear to everyone? Now see the next thing. See, HCF is the product of smallest power of each common prime factor in the numbers, and LCM is the product of greatest power of each prime factor involved in the numbers. What does this mean? Let me explain. See the previous example, we have 45 and 63. We are writing 45 as 3 multiply 3 multiply 5. We are writing 45 as 3 multiply 3 multiply 5, right? And 63 as 3 multiply 3 multiply 7, right? Now see this 45 as it is, 3 multiply 5, can I write it as 3 square multiply 5? And for 63, can I write it as 3 square multiply 7? Right? Now in 45 and 63, which is the smallest common prime factor? Here common prime factor is 3 square. And the smallest power is, by chance we are having 2 as the power of 3 in both the cases. So HCF here is 9. 3 square means 9. And when we talk about the LCM, we have to take the product of greatest power of each prime factor. Each prime factor involved in the numbers. We are not talking about common prime factor. We are talking about each prime factor. Means we have to take 3 here, we have to take 5 here, and we have to take 7 also. Now for 3, we are having 3 square and 3 square in both the ones. Now we have to take the greatest power. Greatest power is 2 only. Now the power of 5 is 1 here, so we are taking 5 only. And the power of 7 is 1 only, so we are taking 7 here. And it is 9 multiplied by 5 multiplied by 7, which is 315. It is the LCM and it is the HCF. Clear? See the next thing now. Find the LCM and HCF of 6 and 20 by prime factorization method. This is again the same thing. We have to do the prime factorization, and after that we have to find the HCF and LCM. For 6, we know that the prime factorization is on 2 we get 3, and again on 3 we get 1. And for 20 we are having 2, then we get 10. On 2 again we get 5, and then on 5 we get 1. So the prime factorization of 6 is 2 multiplied by 3, and the prime factorization of 20 is 2 multiply 5. Now we can write 20 as 2 square multiply 5, right? See, now we have to find HCF and LCM. When we talk about HCF, we have to take the prime factors, the common prime factors only, and the smallest power of those common prime factors. In 6 and 20, the common prime factor is 2. Can you see it? The common prime factor in 6 and 20 is 2. So I am writing 2 here. Now we have to think about the power. We have to take the smallest power of the common prime factor. In case of 6, the power is 1, and in case of 20, the power is 2. Out of 1 and 2, which is the smallest one? It is 1 only. So for HCF, we have to take the power as 1. It means HCF of 6 and 20 is 2. Now, when we talk about LCM of 6 and 20, LCM of 6 and 20. Now for LCM of 6 and 20, we have to take all the prime factors. All the prime factors means in 6 and 20 we have 2 common prime factor, right? In 6 we have 3, and in 20 we have 5 also. Now we have to take the powers. And for LCM, we have to take the highest power. See this thing. We have to take the greatest power. Can you see this? Greatest power means we have to take the highest power. Now if we have to take the highest power, in 6 and 20, the highest power of 2 is 2. So we have to take the power of 2 as, we have to take the power of 2 as 2 here. We have to take the greatest power, highest power, and we can see the greatest power of 2 is 2 here. So we are taking 2 square. Now in case of 3, only 1 power is there. So we are taking 1 power only. And in case of 5, also there is 1 power. So we are taking 1 only. Now it is equals to 2 square is 4 multiply 3 multiply 5. It is 12 multiply 5 is 60. It means LCM is 60 and HCF is 2. Okay? Clear everyone? Now see the next question. Find the LCM and HCF of the following integers by applying the prime factorization method. This is also the same thing, but here we are having three numbers 12, 15 and 21. We have to find the LCM and HCF of three numbers. First we will do the prime factorization of all the three numbers. For 12 we get 6 on 2, then again on 2 we get 3, and then again on 3 we get 1. For 15 it is 3, on 3 we get 5, and on 5 we get 1. For 21 it is on 3 we get 7, and on 7 we get 1. It means we can write 12 as 2 multiply 2 multiply 3, which is 2 square multiply 3, right? For 15 we can write 3 multiply 5, and for 21 we can write 3 multiply 7. Now see, we have to find LCM of 12, 15 and 21 and HCF of 12, 15 and 21. Now see, how can we find that? You know that let's talk about the HCF first. You know that you have to see the common prime factor of all the numbers first. Now in 12 we have 2 and 3. In 15 we have 3 and 5 as prime factors, and in 21 we have 3 and 7. So the common prime factor is 3. So I am writing 3 here. Now you have to take the smallest power. All the three numbers have only one power of 3. So HCF of 12, 15 and 21 is 3 only. Now in case of LCM, we have to take all the prime factors. Let's start from the number 12. In 12 we have two prime factors, 2 and 3. So I am writing both the numbers. Okay. In case of 15 we have 3 and 5. 3 is already written here. Now I am writing 5 also. Now in case of 21 we have 3 and 7. 3 is already here. So I am writing 7 here. Clear? Now for LCM we have to take the greatest powers of the prime factors. Now let's see the greatest powers. 2 has the greatest power as 2. So we have to take 2 square here. 3, in all the cases 3 has only one power, so I am writing only one power here. 5 also has one power, greatest power is 1. So 1, and 7 also has one greatest power, so it is 7. Now you can just simplify it. It is equals to 2 square is 4. 4 multiplied 3 multiplied 5 multiplied by 7. You can solve it. Right? It is 4 into 5 is 20 multiplied 21. It is 420. So LCM of 12, 15 and 21 is 420 and HCF is 3 only. Clear? Now see the next question. 17, 23 and 29. Now see, in this case, you can see that 17 is already a prime factor, prime number. In this case, you can see 17 is already a prime number. So, we can only write 17 as 17. 23 is also a prime number. So, we can write 23 as 23 only. And 29 is also a prime number. So, we can write 29 as 29 only. Now, for HCF, we have to take the common factors, highest common factors. Now, as there is no common factor in 17, 23 and 29, it means the common factor is 1 only. So, is the highest common factor. Clear? And when we talk about the LCM of 17, 23 and 29, for LCM we have to take the prime factors with the greatest powers. The prime factors of 17, 23 and 29 are all these three numbers. So it is 17 multiplied 23 multiplied 29. It is the LCM of these three numbers. Clear? There is no common factor in 17, 23 and 29. So the highest common factor is, no common factor means only one is the common factor. So the HCF is 1 and LCM is 17, 23 and 29. Okay? Let's move to the next question now. 8, 9 and 25. Now, let's do the prime factorization of 8 first. 8 is, on 2 we get 4, again on 2 we get 2 and again 2 we get 1 only. Now for 9 it is, on 3 we get 3, again on 3 we get 1. And when we do the prime factorization of 25, it is on 5 we get 5 and again on 5 we get 1. So the prime factorization of 8 is 2 multiplied 2 multiplied 2, which is 2 raised to the power 3. Right? For 9 it is 3 multiplied 3, it is equals to 3 square. And for 25 it is 5 multiplied 5, it means it is 5 square. Now when we talk about the HCF, for HCF we have to take the common factor and we can see that 8 is 2 cube, 9 is 3 square and 25 is 5 square. So there is only one common factor, which is 1. It means HCF of 8, 9 and 25 is 1 only. Okay? And when we talk about the LCM of 8, 9 and 25, we have to take the prime factors with their greatest powers. Now we have to take all the prime factors. So for 8 the prime factor is 2, for 9 we have 3 and for 25 we have 5. And we have to take the greatest power of 2, it is 3 only. For 3, greatest power of 3 is 2 here and greatest power of 5 is also 2 here. It means the LCM of 8, 9 and 25 is 2 cube multiply 3 square multiply 5 square. You can solve it easily, right? So, HCF of 8, 9 and 25 is 1 and LCM of 8, 9 and 25 is 2 cube multiply 3 square multiply 5 square. Clear? Now let's move to the next question then. Yeah, here it is. You have to find the HCF and LCM of 6, 72 and 120. Again you have to do the prime factorization first of all the three numbers. For 6 it is 2, on we get 3, on 3 we get 1. For 72, smallest prime factor is 2, on 2 we get 36, again on 2 we get 18, then again on 2 we get 9, then 9 is divisible by 3 and then again 3, 1. And when we talk about 120, smallest prime factor which divides 120 is 2, on 2 we get 60, then again on 2 we get 30, again on 2 we get 15 and on 3 we get 5 and on 5 we get 1. Now from here we can write 6 as 2 multiply 3, right? When we talk about 72, see here we have 2 3 times, so we can write 72 as 2 cube multiply. We have 3 2 times, so we can write it as 3 square, right? And for 120, the power of 2 must be 3 here, as we have 3 times 2. So 2 cube multiply. Next is 3 and next is 5. Right? Now, for HCF, we have to take the common factors and the smallest power of those common factors. Now see, in case of 6, 72 and 120, we can clearly see that all these numbers have 2 as the common factor. So we can write 2 here. And the smallest power which is the common is 1 only. So we are taking 1 power only. 3 is also the common factor. So I am writing 3 here, and the smallest power is here it is 1, here it is 2 and here it is 1. So the smallest common power factor is 3 raised to the power 1. It means it is 2 multiplied 3 only, which is 6. So highest common factor of 6, 72 and 120 is 6 only. And when we talk about the LCM of 6, 72 and 120, we have to take all the prime factors and the greatest power of all those prime factors. Means the first prime factor is 2 and the greatest power of 2 here in all these three numbers is 3. So we have to take 2 cube multiply. Next prime factor is 3 and the greatest power of 3 in all these three numbers is 2. So we have to take 3 square. Next prime factor is 5. So we have to take 5 also. So the LCM of 6, 72 and 120 is 2 cube multiply 3 square multiply 5. Clear? Now see the next question. The largest number which divides 70 and 125, leaving remainders 5 and 8 respectively are. We have to find the largest number, means we have to find HCF. HCF of which number? Of those numbers which gives the remainders 5 and 8 on dividing 70 and 125. Means if we subtract 5 from 70 and 8 from 125, then whatever number we will get gives the remainder 0. Then 70 minus 5 is 65 and 125 minus 8 is 117. Means we have to find the HCF of 65 and 175 now. Clear? Now to find the HCF of 65 and 117, means we have to find the HCF of 15 and 117. To find the HCF of these numbers, we have to find the prime factorization. The prime factorization of 65 is on 5 it gives 13 and on 13 it gives 1. And for 117 we have on 3 it gives 39. Then on 3 it gives 13 and then on 13 it gives 1. So for 65 it is 5 multiply 13 and for 117 it is 3 multiply 3 means 3 square multiply 13. And we have to find the HCF, means HCF is highest common factor and highest common factor is 13. So the answer is 13, which is option number A. Clear? So option A is the correct answer. Now see the next question. Yeah. Before solving the next question, see there is a thing that HCF is always a factor of LCM. When we find the least common multiple and the highest common factor, in both these numbers, HCF is always a factor of LCM, means LCM is divisible by HCF. Or we can also say that HCF always divides LCM. Clear? Now, see the next question now. The LCM of two numbers is 2400. Which of the following cannot be their HCF? See, we had just now learned that HCF is always a factor of LCM. If it is a factor of LCM, then it must divide LCM. It means out of all these four options, We just have to find which number divides 2400, means divides LCM, and which does not. If it divides LCM, then it can be the HCF, and if it does not divide the LCM, then it cannot be the HCF. When we talk about 300, first option, it clearly divides 2400. When we talk about 400, it can also divide this. It can also divide 2400, right? When we talk about 500, here we get 24 upon 5. It means it cannot divide 2400. And if we talk about the fourth option also, 2400 upon 600, it is also dividing this, right? It means 500 cannot divide 2400, means 500 cannot be the HCF of those two numbers whose LCM is 2400, means third option is the correct answer. Clear? Now see the next one. Now we have relation between HCF and LCM of two numbers. We just learned now what are HCF, what are LCM, and how to find the HCF and LCM. Now we have a relation between these two numbers. Whenever we are taking two numbers and we are given with HCF or LCM, or we have to find the HCF and LCM of two numbers, there is a relation. That relation says that when we have two numbers, two positive integers A and B, and we are multiplying the HCF and LCM of these two numbers, then it is always equal to the product of those two numbers. Okay? HCF and LCM of two numbers, any two numbers which are given, when we multiply them, then it is always equal to the product of those two numbers. Product of those two numbers. Clear? Let's see it with an example. Yeah. See the question. Here we are given with HCF of 96 and 404 is 4. HCF is given, which is 4, and the two numbers are 96 and 404. And we have to find the LCM. I just told you the formula that HCF of two numbers multiplied by the LCM of those same two numbers is equal to the product of those numbers. Right? It means now HCF is given to us as 4. It means 4 multiply. LCM, we have to find the LCM. It is equals to 96 multiply 404. Now here 4 is in the multiplication. When it goes on to the right side, it will go in division. So LCM is equals to 96 multiply 404 by 4. We can cancel 4 and 404 on the table of 4, and we get it equals to 96 multiply 101. Right? And you can solve it very easily. Right? It is the LCM. See the next one more question. Now we have HCF is given. The two numbers are 306 and 657, and HCF of these two numbers is 9. We have to find the LCM. Again we have to use the formula HCF multiply LCM equals to product of numbers. Product of two numbers. So HCF is 9 given to us. We have to find LCM, and the product of two numbers means 306 multiply 657. Now LCM is equals to 306 multiply 657 divided by 9. On the table of 3 we can divide 9 and 306. It is 102. Again on 3 it is 1 and it is 34. So LCM is 34 multiply 657. You can solve it very easily now. Right? and hence you get the value of LCM. Clear? Now, the next one is the HCF and LCM. See, in this question, there is something different. Now, we are given with HCF and LCM both. HCF is also given, LCM is also given. And one of the number is given. Let HCF, we know the formula, HCF multiply LCM is equals to product of two numbers, means A multiply B, right? First number is A, suppose, and second number is B, and we are taking HCF and LCM, means we are taking the HCF and LCM of A and B. Now the HCF is given as 18 and LCM as 3780, right? And one number is given, means we are taking the value of A as 540 and we have to find the other number, means I am writing B here. So from here, B is equals to 18 multiply 3780 by 540. 0 and 0 will get cancelled out. Now on table of 18 we can cancel 54 and 18 at 3. Now on the table of 3 again we can cancel them out. It is 1, 2 and 3 6 is 18. So the second number is 126. Clear? Now see the next question. Yes. It is the HCF and LCM of two numbers is 9 and 360 respectively. Means 9 is HCF and 360 is LCM. One of the number is 45. You have to find the other number. Again we have to use the same formula, that is HCF multiply LCM equals to product of the numbers A multiply B. HCF is 9, LCM is 360. We just put the values of HCF and LCM which are given in the questions. It is equals to one of the number is 45, means let A is 45 and we have to find the other number, means we have to find B. Now B is equals to 9 multiply 360 by 45. Now on the table of 9 it is 3, 9 1 is 9, 9 5 is 45 and 5 1 is 5, 5 7 is 35 and it is 2. So the other number is 72. Other number is 72 when one number is 45 and HCF and LCM are 9 and 360. Okay. So it was all for today. If you like the session, then please like and comment as much as you can and also subscribe the channel. Thank you.